Hi, guys. Just when you thought you were rid of me, I've come back with the power of YouTube. I just didn't want to leave you stranded, and I'm so picky about the way you do this that I wanted to teach you myself. So, lesson 2 is about bar graphs, and it's something you've probably already done, but we're going to look into how we can lie with bar graphs, which is going to become very interesting. So, first, let's start with the basics about what a bar graph is and how we draw one. So, with a bar graph, we use bars to represent categorical data. We talk about data as either quantitative or qualitative. And quantitative means quantity. It means it can be counted. So that describes the amount, and the data has values that are numerical. So one of the ways I think about that is I put a little star here and say can be counted. Now, please don't listen to all the noise in the background. Brendan's baking a cake, Podrick's banging on the window, and Guinness is moseying around. So, sorry, guys. Okay, back to this. The qualitative axis means a quality. So it's divided into different bars or columns, if you prefer. And the important thing here is that the values are classifications or categories, so they're discrete, and they are not touching each other. And that's really important, you guys. I will deduct marks if they're touching. Guinness, stop it. He's sitting here licking my feet. Okay, so example 1. Which of the following are qualitative and which are quantitative? So let's just start with that at first. And I want to apologize too, because this printed a little bit funny and lines are missing and it looks a little bit ugly, and it's too late for me to fix it, or else I would. So first of all, let's look for things that are quantitative, meaning that we would have a number associated with them, versus qualitative, which means it's a category. So quantitative would be something like weight, because we measure it with a number. So let's put quantitative. And obviously, if something says number of A's in a class, that would also be quantitative. And this says number of voters who prefer a certain issue, if you couldn't guess what that said. So this is the number of, so this must be quantitative as well. The number of spectators at each of 20 hockey games, that would be quantitative. Time taken to score the first goal in each of 20 hockey games, well, time is definitely a quantity. And this is number of students in a class having birthdays in each month. Well, that again, number of students, that's a quantity. Oops, I made a little mistake there, guys. Now, this is a bit of a weird question, because some of these are really talking about two different things. For example, the number of students in a class having birthdays in each month. Well, a month is a quality, right? So we have to be careful about which one we're actually describing. The big idea here is I want you to understand which of these quantitative things are discrete. So discrete means countable in whole numbers. So, for example, the whole numbers start at 0, 0, 1, 2, 3, 4, 5, 6, 7. It's not like 2.5, 13 3/4, 0.9999. So let's go back and think about that. What about weight? Could you have a weight between 2 kilograms or between 2 pounds? For sure you can. So that is not discrete. What about the numbers of A's in a class? Well, either you have an A or you don't. So you're just going to count in the counting numbers. So this is what we would call discrete. The number of voters is the same thing as the number of people. And we can't have half a person. So whenever we're talking about people, it is discrete. So again, number of spectators, that's people. And number of students, that's people again, so it's discrete. I think you guys caught me there. I was writing people and I meant to write discrete. Okay, let's go back to the ones we haven't talked about. Time taken to score the first goal in each of 20 hockey games. Well, time is definitely measurable in more than just the counting numbers. So this is not discrete because you could have 7:30, 7:29 and 33 seconds, 8:05 and 21 seconds, and on and on and on. So the one we haven't talked about is occupation. Well, occupation is what you do. So you're a teacher, you're a nurse, you're a politician, you're a graphic artist. Whatever you are, it's a category. So we know that that's going to be qualitative, not quantitative. Now, the reason why we're doing this is because the only things that we actually put into bar graphs are those things that are quantitative and discrete. So that's what we're going to be looking for if you're given some data and not told how to represent it, that you're looking for quantitative data that's discrete, that can be broken into categories. So there are some hints about things that I will look for when drawing bar graphs. And again, this got cut off because I did something weird with my printer. Sorry about that, guys. So what am I going to look for? I'm going to look for the title of the graph, title and labels for the x-axis, that's the horizontal, the y-axis, which is the vertical, accuracy, and some sort of legend, especially if you're using a double or triple bar graph. And I have some steps here, and here in big letters it says always use a straight ruler or straight edge. So to help me teach this, what I'm going to do is go through these steps while we look at the first example. So here is the first example. So I'm going to have you look at the data while I go through the steps. Step one is the data must be discrete and sorted into categories. Well, yeah, see, these are all whole numbers, right? We don't have decimal numbers or fractions here. And these are the categories: the favorite sport, hockey, football, basketball, soccer, or other. So yes, this is definitely something that we would use a bar graph for. Also, the question says, use a bar graph. But again, later I'm going to say, here's some data, represent it. And I won't tell you that you need a bar graph. You have to decide that. So step one is done. Next is determine the maximum value of the sorted data. Well, 450, right? That's the maximum number of people, especially Go Jets Go. Of course they are. Hockey's number one right now. And now we have to determine the scale of the quantitative axis. So I went ahead and I looked at that piece of graph paper I gave you on this page, and I realized that there were 15 boxes going up. So I took 450 and I divided it by 15, and I found that there were 30 units left over. So the way I represented the data is I said, okay, let me zoom out here a little bit, guys. I know this is a bit annoying. I said, let's go from 0 down here all the way up to 450 in 30s. Okay? And then I put on all my labels, and if you look closely, I left a space. So I did two bars for hockey, left a space. 2 bars for football, left a space. 2 bars for basketball, left a space. 2 for soccer, and 2 for other. I did that, or else it would be all scrunched up, and I didn't really want that. So we need to label these axes, and we need to put a title on, and you need some time to catch up to where I am. So press pause on the video until you all have this in 30s. You have a nice quantitative axis along the horizontal, and you have some titles. Don't fill in the numbers yet. So just press pause until we're all caught up, please. Okay guys, so we're back. So I've put a title on this. Yours might be slightly different, but what is this graph telling us about? It's telling us about the number of people who prefer each sport. Again, underline your title. And then on the vertical axis, we have the number of people. And on the horizontal axis, we have favorite sport here. So where did I get those labels? Well, exactly from our table of values. Favorite sport, number of people. It's already done for us. So that's pretty straightforward. So there we go. So let's go back to our list of things we should be looking at. So we've already done step 1, step 2, step 3, step 4. Now we have to draw the bar for each category. The value of the category will determine the length of the bar, and the bars must not be touching. Well, we kind of already dealt with that with these little spaces that we've done. Now I'm going to go back here and circle this. Always use a ruler or a straight edge, okay? Picky McPickerson is going to be marking this, and I will be looking for really quality, beautiful graphs, you guys. So let's go back to our data, and I see that hockey is 450. So this is how I do this, guys. I start by putting in my maximum value with a line. So this will be at 450, and it will go over these two lines here. So there's my maximum. I did a nice job. So now I can connect that down. And later I'll share it, or sorry, shade it. My next value is football at 240, and look at how nice that is. 240 actually happens to be a mark right here, so I don't even have to guess or estimate where 240 is. So I'm just going to go ahead and do all the horizontals and go back and shade in later. Basketball is 90. Well, that's kind of nice because 90 should also be right on there because it is a multiple of 30, which is how we decided on our scale, and I almost made a huge mistake. Look, I put the dot in the wrong place. That's okay. Saved myself before it was permanent. Soccer, 158. Okay, well now here we're going to have to think a little bit. So 150 is here and 180 is here. So what's halfway between 150 and 180? Well, that would be 15, right? So 165. So it's going to be less than halfway. So it's not going to be perfect, but I could be pretty close. There's my 158. And my other is 62, which is essentially going to be right on top of this 60. So we can take another minute, just pause the video, connect these down to the x-axis, and let's shade these a little bit. Okay, so here is my finished bar graph. There's spaces between each. Everything is nicely shaded. The categories are clearly marked. The axis on each is marked, and there's a title. So this is what I'm looking for full marks. Watch video 2 to learn about bias in bar graphs.